Hello, everyone. Welcome to the Data Science Mentorship Cohorts. My name is Pablo. I am a data scientist, and today we are placing our focus on the decision tree versus the random forest. Now, again, just so you know, the Data Science Mentorship cohort is an accelerated learning cohort for anyone starting data science from scratch, data science and machine learning. And it is important to state that data science and machine learning are fundamental to understanding AI generally. So it's important to pick this up. And so that's what we do at this cohort. And today we're looking at the random forest algorithm, or the random forest estimator, and the decision tree estimator. We had looked at decision tree estimator in our last session. So if you have not seen the last session, you could go check it out. You should have access to it in the drive, and then you check that out. Now today we're going to be looking at both algorithms, in the sense that the decision tree is prone to overfitting. So if you think about it like you're making decisions and then you overthink it, think about the decision tree like you overthink stuff because it's just one person. But imagine if you had you had to legislate thinking to like 100 other individuals, and then when they can't bring their ideas together, we average them to say, okay, these are the decisions we're going to make. So what we're going to do in today's session is we are going to create a decision tree. We're going to do a walkthrough on what decision tree is, even though we found that in the last session. But the idea is to now do the same thing with the random forest and see if there's some sort of like a difference. So let's get stuck in. So the first thing we're going to do is I'm going to import the model classes. So we're going to import the model classes. Now the model classes are the model classes that we're going to use going to be, it's already there, but we're not going to be using this one. But this is one we will use, but let's bring it up. We're going to also say we're going to go from sklearn datasets. And then we're going to also import make moons. We're going to import that. Then we're also going to say from sklearn, we are also going to import a decision tree classifier. So we are going to do this. Also, we are also going to say, from matplotlib .pyplot. We're going to import. No, why did we say that? Why did I even say that? So no, we're going to import this. We're going to import matplotlib as PLT. Any other one? Yes, I think all this works. So run this. Now this is done. Next, what we're going to do is we are going to create X and Y. So we're going to have X, Y. And again, is a reflection of how the data representation for scikit-learn estimators. Right. Now, what we're going to do is we are going to have a bunch of samples, and we're going to create some noise, and we'll put our random status 1. Right. So this is this. And then this sets it up for the next. Now, the next thing we will do is we're going to visualize. So we're going to visualize the data set. So we will visualize the data sets. Now, to do that, what we would want to do is we're going to do a scatter plot, right? We're going to do a scatter plot, and we're going to break the scatter plot into two places, and then just as you've seen here, we would make them. We'll use the Y to basically break it down. Right, we'll use the Y to break it down. An additional thing, Y, which is our target vector. Now, additional thing we're going to do is we're going to have edge color, and we'll have edge color as K. Yes, that's what we're going to do. Now, which is we're going to have this. Now, the next thing we're going to do is we're going to have the two interleaving moons, and then we can run them. And then we'll see what we have here. Now, so this is what we have. Now, you have seen this before, right? And if you had followed the last session, you've seen this. All right. Now, the next thing we want to do is we are going to fit the decision tree. So that's the next line. We're going to fit the decision tree. Now, to fit the decision tree, we are going to have this here. Now, I'll take this, but however, I'm going to say .clf. So we know that this is the random classifier. My max depth is going to be 5, and my random underscore states is going to be 1. So that's the decision tree. And next, we will now take the tree, and then we'll go on to fit it in here. Now, this, when we run this, we basically built a decision tree classifier. Now, remember, the best practice part is always there, and I will always mention that typically you would want to split your data points, and you would want to have you want to have validation sets and all. But at this point, we're trying to learn stuff. Now, next thing is I am going to create a grid so I could visualize the decision tree, the decision regions, right? So the next we're going to do is I'll put the code here. Now, interestingly, right, what makes it so interesting using like the Google Colab is, you know, the AI tool behind just makes it pretty easy for you to, you know, pick up stuff and just run with it. So at every point that I write my comments, then my comments typically I just get a sense of what the code would be like, and I think it's pretty cool, right? So we'll create so we're going to create a grid. Create a grid to visualize the decision, to visualize the decision region. Let's see. All right, so what we're going to do, we're going to look at the decision regions in many ways. So let me see. Oh. So first things first, we are going to have this. And so we're going to have 0 minus 5, and then we're going to go on to introduce 0, and then dot max. And then we would now go on to add 0.5. So now what we are doing at this point is we're creating a grid, right? Now this grid would make us see like the minimum, maximum in terms of the decision, how we're going to end up trying to figure out the way that decisions were made in terms of boundaries. And then we would proceed to see the difference between that and that and random tree. So that's what we're setting up. Now, next is we're going to look at why it makes it pretty easy for me to work with dot max plus 0.5. Now, the next, no. Now, the next we're going to do is we're now going to split it into a mesh grid. So we're going to have XX, YY, and we're going to say NP into a mesh grid. And we're also going to say NP.aRange, right? So this is typically what we're looking to do. Right, so we've gotten that. Now, the next thing we're going to go is I'm going to create a Z. Now, what the Z is we're going to flatten our classifier. We're going to flatten our grids, and then we're going to reshape them. Then it makes it easy for us to visualize what we've done. Yeah, so I think this is pretty much it. Then we can have a shape here. Right, so let me run this. Hopefully we shouldn't have any error. If there is, we can always sort that. Next, what we are going to do is we are now going to take we're now going to plot. So we're going to plot, right? Now for plotting, we're going to basically take a look at a contour plot. So we're going to say plt dot contour, right? And we're going to say CMap. It's going to be O1 and alpha. Now alpha is going to will be 0.3. Then we're going to now say plt dot scatter plot. Again, what we're going to now do here is we are going to take this. Where are you? Yeah, we're going to take this. Let's copy this. This is what we want. We're going to take this here, and we're going to take it over here. So bring it down here. Right, so this is what we're going to take. Now, next thing is we are going to say plt.title, beautiful decision tree region, and then we'll plot. Now you can see that now if you look at the decision, the way the decision tree basically look at the tree, you can see it's trying to break some things down, but you can notice at this point, hold on, let me get my annotator. That would work. Now you can see that sort of like whenever the noise it tries to fit into the noise, right? And you can see that the boundaries is sort of it doesn't really look, smooth in a way. So the boundaries don't look smooth, and we're going to know this by the time we check out by the time we now train and visualize a random forest, right? So that's the next thing we're going to do. So next thing I'm going to do is we're going to train and visualize a random forest. That is what we're going to do. We're going to train and we're going to visualize the random forest. Now, to do this, what we are now trying to do is that we're going to see how the random forest typically uses like a voting process to make sense of use the voting process to make sense of its decision regions, right? So we've already imported our decision tree here. You can see where was that from from the outset. We had done that already. Yeah, over here. So we have the random forest classifier. Now we're going to come here. Now the first thing we want to do is to fit the random forest, right? So here we will fit the random forest. Now, if we're going to fit the random forest, we would, I like to call this, okay, let me call this forest, right? So the random classifier estimate is 100, random state is 1. Then I'll have forest underscore CLF, which is what we have. And then dot fit. And that's going to be X, comma, Y. So we'll run that. Now, the next we're going to do is, just like we did, we are going to predict on it. We're going to do a prediction, right? And again, just like this, just like we did the prediction here, right there, and flatten it, we're going to come over here and do the same. So here we're going to predict on a grid. So we're going to predict on grid. So yeah, right. So you can see pretty much what we have going on. We're going to predict on this and flatten it, and then go on to pick up the shape. So this is xx dot shape. Right. Yeah, so that's what we did here, and we run this. This should be fine. Now the next step, just like we did, is we are going to plot. Now we're going to do a plot here. Let me see. Yes, it's the contour plot as usual. Yes, let me see. We got that. Alpha is 3, PLT dot scatter. Yes. Great. So it's PLT dot scatter, and just like we did the last time, we pick this up. We say PLT dot title. Yes, which, and this is the random forest region, and PLT dot show. And then we run this. Now, you can now see the difference, right? You would notice that over here, it looked all rigid, right? The boundaries are rigid. And you can see that the noise here sort of cuts the estimator off guard. The noise here caught the estimator off guard, right? And you can see that there's sort of like noises over here. You can see them over here. Now look at the difference, right? See the noises sort of like smooth, right? So now the boundaries are smoother and less sensitive to the noise. Even you can see over here that there's a noise over here, but it sort of does not get caught up on that. So the random forest basically average out overfitting tendencies, and that's what's happening over here. Now, so each tree sort of like a random sample, and then it sort of understands what's going on without overthinking that. So that way, we can now get to see that this generally comes together to tell the story. What can we do? So let's the final part of what we're going to do is we are going to plot. We're going to plot. We're going to show the models together for visual comparison. So here, let me just write. We are going to show the models together for visual comparison. Right. So let's see if we get a sense of what it is. So first things first, we are going to get both let's see. I already have like a breakdown of it, so let me just get the code here. So we don't have to go through that then. All right. So what we could do is we could just make some changes here. So we can see that it's for our decision tree. Yeah. So we see our decision tree here. We're going to see just a little bit. Yeah. So here, so we have three that we have our forests.clf. Right. So let me see. Is everything in other? Let me call this. And if we have an error, we can always just set it as we go. So now you can see that right now we have our decision tree here. You can see how the overfitting, so like the overthinking. Now I'm just going to focus on these areas for you to see. But if we move over, and this for the decision tree, and this for the random forest, you can see all these areas are pretty smooth. So that's so typically you can see that the decision trees they sort of jagged and they fit to the noise. Why for the random forest it is smoother and there's better generalization. And this is why the random forest, you know, typically takes a step ahead of the decision tree. And that's why they're called like ensembles. They come together, the vote, the general thinking population and all, and you know, gets an average of what the thinking population has and say, this is what we know. At the end of the day, you see that there's a difference between these two. And also, this is generally what it will look like if you were using, and this is a template you could use. And when you're trying to do a visualization or you're trying to predict, you know, using a random forest and a decision tree. Now, best practice, you use a decision tree at first, see how it turns out, and visualize it as you go, because that's super, super important. Again, I just want to mention that this is the first time I am using the Google Colab. First time using the Google Colab, and it's sort of like smooth. You can see that with the AI tools like Gemini, pretty helping out here just to get us to get things done as quick as possible. And I think it makes a lot of sense, right? Right. So, so please jump on it. Try as much as you can to use Gemini, to use Google Colab. We had used the Anaconda notebooks, really great, right? But I mean, you can also try out using Google Colab to sort of like helps to put things in perspective as you work. But remember, you have to know what you're doing. So when you type out your idea, not for this, but for others, you can see that it just gives you a hint, right? Then you can now work with the hints and makes it sort of like easy and smooth for you to learn. So yeah, so that's that for decision tree versus the random forests. Or you can watch this again if you need to make sense of it and all. And yeah, if you got any questions, please feel free to drop it in the comment section, or you can, if you're live in the class, you can ask a question. And if you're watching the recorded session, then feel free to drop any question in the Telegram chat or the channel. Yes. All right.